Hello, I'm Vanessa, and I'm going to be working a problem for us today, a chemistry refresher problem, and one specifically to help you get back up to speed on chemical reactions with acids and bases. So here I have a sample problem for you, and it says, identify the molarity of the salt that results from the addition of 0.4 grams sodium hydroxide to 50 milliliters of 0.1 molar nitric acid. Now this problem has a lot of different pieces to it, and the best starting point is to find out what is our balanced chemical reaction. And to get to that, we need to identify what our reactants are. So what is sodium hydroxide? We can start off by looking at the periodic table and noting the charge on our elements. Here we see that sodium is in column 1, and these ions have a +1 charge. In the next column over, these have a +2 charge. Moving over to the right side of the periodic table, the column with nitrogen is 3-, O 2-. The halides are 1-, and the noble gases are 0 in their state. So we know that sodium, we're going to start off with sodium plus, at least in this reagent. Hydroxide, what is hydroxide? Well, you should recognize that hydroxide is a strong base, but we can also look at the polyatomic ions, and you should become familiar and know these. But you see here that hydroxide is OH-. So we know that sodium hydroxide is going to have a sodium and an OH- in it. In its normal form, it's going to have to be neutral, so we would need to have the charges balanced, plus and a minus. That works out. So sodium hydroxide, NaOH, is our first reactant. Nitric acid, what does that look like? Well, nitric acid is one of the 7 strong acids, which you should also know. And you can also look at the polyatomic ions again and note that nitrate is the counter ion for that. How do you know that nitrate is the one that you would look for? You can remember that all of the ic acids, their counter ions go by the name of 8. So nitric acid would become nitrate. So in the equation, we would have NO3, and since this is an acid, we would have H out front. So HNO3. Okay, so this is the left side, our reactant side. Oops, just bumped that. The left side of our reaction, what goes on the right side when this reaction happens? Well, this is an acid-base neutralization problem, which you can see an example of right here. An acid and a base react to form a salt and water. And since this is a strong acid and strong base, nitric acid and hydroxide, this will make 100%, react 100% to make water, and then the other 2 ions will react together to form sodium nitrate. So this is our left side and our right side of the reaction. Now we need to ask ourselves if everything is balanced. You see you have 1 sodium here, 1 sodium here, 2 protons, 2 hydrogens or protons here, and then our oxygens also balance out. So that is our chemical reaction. Okay, now we need to know how much of each reactant we have. And you have some information of how to get there given in the problem here. You see that you have 0.4 grams of sodium hydroxide and then this amount of nitric acid. So in order to relate these two together in their reaction stoichiometry, we need to find how many moles of each we have. So for sodium hydroxide, we're actually given a weight of this, 0.4 grams. And you can convert this to moles using the molecular weight of sodium hydroxide, which is 40 grams per mole. Now, don't freak out about how I got that. Oftentimes we will give this to you in the problem, but you can easily find this using your periodic table. So sodium hydroxide, the atomic weight is given here. Make sure I get that on the screen. Here's sodium. H is right there, 1.01, and oxygen here. So you can simply find the atomic weight by taking the sum of that. 1.01 for hydrogen plus 16 for oxygen, and that equals 40. So if we don't give you that information, you can easily find that on your own. So knowing that the molecular weight for sodium hydroxide is 40, we can now set this up to cancel out grams and get our moles. And we find that we have 0.01 moles of sodium hydroxide. Okay? Okay. And what about nitric acid? We have 0.1 molar nitric acid. Remember that molarity is equal to moles over volume in liters. So since we've given you the volume of nitric acid and its molarity, you can convert that to moles. So if you just plug this in, you have 0.1 molar equals X over 0.05 liters. 50 milliliters. If you just move the decimal here over to the left 3, that would give you 0.05 liters. So to find X, we find that X is equal to 0.005 moles of nitric acid. Okay, so now we know how much of each we have. Now we need to determine which is the limiting reactant, because we have different amounts of each. So let's just get a fresh piece of paper. And if we rewrite this, NaOH and nitric acid are reacting to give us water and sodium nitrate. Okay, so the way we like to solve these types of problems here is by setting up a Rice equation. And Rice is just a little acronym to help you remember how to set this up. The R stands for your chemical reaction, which we've written here. I, C, and E, we will start to fill in. So I stands for the initial amount that you have of each, and in moles. And so we found earlier that we have 0.01 moles of sodium hydroxide and 0.005 moles of our nitric acid. And we don't have any of these things on the right to start off with. Okay? And then C stands for change. So if we